Hello everyone, this is Professor Weber. In this video I'm going to be going over section 5.7 of the MAT006 pre-algebra and algebra curriculum. So again, this is section 5.7, mixed factoring, where we go over all the different types of factoring that we discussed back in sections 5.2 and 5.6 from the text. So previously in the textbook, the polynomials were grouped together according to the method used to factor them. So 5.2 is basic factoring with leading coefficients of 1 in front of the x squared. 5.3 dealt with leading coefficients other than 1 in front of the x squared. So we used the trial and error or AC method. 5.5 dealt with DOPS expressions, difference of perfect squares. And 5.6 dealt with those PSTs, perfect square trinomials. So we begin this section with a checklist that can be used in factoring polynomials of any type. So this is the checklist that you want to go through anytime you come across a factoring question, be it on homework or be it on an exam. When you have finished this section and the problem set that follows, you will be proficient enough at factoring that the checklist is second nature to you. So again, you want to go through the checklist every time that you are approaching a polynomial expression that needs to be factored. Okay, so here's our checklist. So in our textbook, this is page 532, and that's also in the ebook. So step 1, and usually the directions will say factor completely, so complete factoring. So step 1, or here it's labeled today, look for a greatest common factor. So that's always going to be your first step. So if there is a greatest common factor other than 1, remove it. So as soon as you see a GCF, make sure you are dividing every term by the GCF and then writing it as GCF and what remains. And remember, the what remains comes from dividing each term by the GCF. So that is the format for when you have a GCF. That's what it looks like. Then you're going to have something inside the parentheses, a polynomial, binomial, multiple terms, whatever it may be. That's when you go to the next step. Step B, how many terms does the polynomial have? Okay, so what if you have 2 terms? That means it's a binomial. So if it's a binomial, follow these steps. Is it the difference of squares? And that's called, in my notes, DOPS. That's what I'm going to be referring to it. Is it a difference of squares? Is it DOPS? If so, factor by using a squared minus b squared equals. First factor is a plus b, second factor a minus b. So what we were doing in class in section 5.5 was taking the first term here, asking ourselves, what term multiplied by itself will give us this value? It must have a subtraction sign. That's why it's difference of perfect squares. And then the second term, another squared term, another perfect square. Again, we ask ourselves, what item multiplied by itself gives us this number or this variable? Then we take those 2 items, place it here and here for the first one, here and here for the second one, and always 1 plus, 1 minus. So that's the standard format right here for DOPS. That's always how we'll look. I scribbled out B because it's talking about sum or difference of Q's. We did not discuss that from section 5.5. That's not part of the 06 curriculum. That's more of what you would discuss in 111 if you choose to pursue 111. 111 is algebra 2. Okay, so really we're only doing one, the first one, 2 terms, binomial, and the difference of squares. All right, back to the question B. How many terms does the polynomial have? Well, what if it has 3 terms? That is called a trinomial. So if necessary, put the trinomial in descending order. I will always have it in descending order already for you, but say the homework or I miss one that excuse me, is not in descending order, please make sure it's in descending order. That means largest exponent first, and then each exponent behind that is 1 less than the previous one. So x to the 4th, x cubed, x squared, x, and then the constant. Just thinking of one example. Maybe, like I said, usually they'll already be in descending order, so you can go straight to B. Is it a perfect square trinomial? Remember, we were calling those PSTs. If so, by factoring this format. Okay, so in the way we were talking about this in class, so this is the generalized setup, is you have a squared plus 2ab plus b squared equals a plus b quantity squared, or a squared minus 2ab plus b squared equals a minus b quantity squared. So the setup I was telling you to do was the characteristics of a PST. So the characteristics again, so characteristics of a PST. First one, last term is a perfect square. We're good here, perfect square. Perfect square. Last term is positive. 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 Third characteristic is middle term tells what signs of the binomial will be. So here you have middle term for the first expression was plus 2ab. So then you had a plus inside the binomial. Second one was minus 2ab minus over here. I put down the first characteristic as being just the last term as a perfect square, but obviously you must also have a perfect square in the first term. You're going to have that either x squared, a squared, b squared, anything, as long as the first term is squared and the last term is squared. But the characteristics that we're always looking for, again, is that last term is squared with a plus sign in front. And then the middle term tells us whether the binomials will be minus or plus. Okay, so that's a PST. If the trinomial is not a perfect square trinomial, factor by using trial and error, or using the AC method. Oh no, I'm sorry. The trial and error method they're discussing here is referring to basic factoring. I was also calling that the MAN method. That's the two types of factoring that we talked about, section 5.2. They're also referring to not a perfect square trinomial is if you have a leading coefficient other than 1, then you'll definitely be using the method we were calling trial and error. And always make sure you're checking your factorization using FOIL. If the polynomial has more than 3 factors, usually you'll see 4 factors at this point. That's just called a standard, polynomial. You're going to go straight to factor by grouping. And then the last thing, the factorization is not complete unless each factor is prime. That means that you cannot factor further. So make sure you are checking all your factors and then factor again if there is something that's not prime that can be factored further. So again, here is our checklist. And this is on page 532 of the textbook and ebook. Alrighty, so now let us do some examples. So again, the first step is to always look to see if this expression has a GCF. And you want to then ask yourself which method would be the best way to factor the simplest terms. The directions primarily will say factor completely. So then you have to ask yourself, okay, if it says factor completely, that means I'm probably going to be doing more than one step within the factorization. So let's look here at number 1. And don't mind my messy handwriting as we do the factorization. So 3x to the 4th power minus 27x squared. Okay, so going back to that checklist, we had step B said how many terms does polynomial have? If it has 2 terms, follow these steps. So I do have two terms here. So I do have a binomial, but is it DOPS? So I put a question mark there because just by looking at it, it's not a DOPS expression. This is not a perfect square. 3 is not a perfect square. Yes, x to the 4th is, but 3 is not. 27 is not a perfect square. Yes, x squared is, but again, 27 is not. So I'm thinking we're going to take out a GCF. So I'm going to take out a GCF of 3x squared. So that means I'm going to take each binomial, so 3x to the 4th, I'm going to divide by the GCF of 3x squared. Pull down that minus. Take the 27x squared, divide by 3x squared. Okay. So the x squares in the tail end cancel each other out. The 3 in the beginning cancel each other out. I'm going to now subtract my exponents here, and I'm going to divide 27 and 3. Remember, the format is always GCF. Do not forget to include your GCF in your answer. So we said the 3x, the 3's cancel out. So now I have 3x to the 4th minus divided by x squared. So I take 4 minus 2. I'm left with x squared. So quotient of like bases, we subtract our exponents. Carry over that minus sign. The x squareds cancel each other out. So now I'm just going to do 27 divided by 3, which is 9. So now before I ask myself, is this a DOPS expression? Yes. This is DOPS, difference of perfect squares. So I am just going to, again, rewrite my GCF, and I'm going to set it up in the format that we had, which was x squared minus b squared equals a plus b times a minus b. So I'm going to have 1 plus, 1 minus. And the question I always gets asked to me is, does it matter which direction you put these plus and minus signs? No. If you want to do the minus first and the plus second, that's fine. It does not matter to me. Multiplication is what we call commutative. Order does not matter. So now what two items, or what, I shouldn't say what two items, what item multiplied by itself gives me x squared? And that is x. What item multiplied by itself gives me 9? Remember, 3 squared equals 9, so I'm looking for a square. So that'll be 3 and 3. Here is my final answer. 3x squared times x plus 3 times x minus 3. So there's our completely factored form for 3x to the 4th minus 27x squared. Okay, let's try another one. So number 2, I have y to the 5th plus 36x cubed. So it's another binomial. But again, I ask myself, is this question DOPS? I don't know. But first things first, x to the 5th, y to the 3rd power, y cubed. Whenever you look for GCFs, you're going to pull out exponents, but always take the smallest exponent. So my GCF here is y cubed. There is no number in front of y to the 5th, so I can't take anything out from the 36. So I'm going to divide each term by that y cubed. The y cubes at the tail end cancel each other out. And I'm going to do 5 minus 3 when I do my division of like bases. So GCF comes first. Y to the 5th divided by y cubed. 5 minus 3 is 2. And then I'm just going to do plus 36. So then the question I ask myself now is this difference of perfect squares? And the answer is no. This is a addition sign. This is not difference of perfect squares. This is sum of perfect squares. And we were calling those in class SOPs, S-O-P-S. A few of you got a kick out of that. But we don't factor SOPs any further. So that is actually my completely factored form. So there we have y to the 5th plus 36y cubed. We get the answer of y cubed times y squared plus 36. Okay, number 3. Number 3, I'm probably going to end up solving 2 different ways. So I am no longer have a binomial here. I have a trinomial. But now I have to ask myself, is this a PST? No. I have a minus sign at the end. Not a perfect square, not a perfect square. So this is going to have to be the trial and error, because I do have a leading coefficient other than 1, and there's nothing that I can take out GCF-wise to reduce this number. So I'm going to do trial and error. So I'm just going to pull this up. So the trial and error method states that you want to play around with the numbers until you get ones that work. So I'm going to think of factors of 15 and factors of 2. I can't use my standard factoring techniques that were discussed in section 5.2 because I have this leading coefficient of 15. It kind of creates a weight on the entire expression, and I can't just go straight to saying, oh, I want 2 numbers, add to 2, multiply to 2, that would add or subtract to 1. I can't do that. So I have to play around with the numbers. Recommendation, usually stay away from the ones that are very far apart. So like the 1 and the 15 are extremely far apart. So when I do my multiplication of my outer and inner terms, when I'm checking my answer, I'm going to get very large numbers. And the goal here by checking the outer and inner terms of my FOIL steps is to see if I match to the negative, this is really -1. So I'm going to stay away from 1 and 15 right now. That's going to be my last resort. So to multiply to 15, I have here 3 and 5. So that means 3a, 5a. Now I want to multiply to 2. So I'm just going to do 1 and 2. So this is the second category of factoring that was discussed in section 5.2. So even though we're not doing 5.2 type factoring, you still can use those techniques. So when I have a minus sign here, that means I'm going to have in my binomials 1 plus 1 minus. But I do not know for sure which one's going to be the bigger and which one's going to be the smaller. So I'm just going to do -1 plus 2. So now I have to check. I have to check here at trial and error. And again, this is called the trial and error method. And I'll do the other method for these types in a minute. So to do my outer and inner, to do my check, I check my outer and inners. So 3a times +2 is +6a. -1 times 5 is -5. When I combine those, I get +1a. So I got the right number, 1, but I got the wrong sign. I was looking for a negative. So basically, I reject this factorization. That's called an error. So now I'm going to do another trial. So I'm going to keep the 3a and the 5a. I'm going to keep the 1 and the 2. But I'm going to change the signs around. And the reason I keep the positions the same is because I got the right number. So that means my multiplication was correct. I just had my signs in the wrong locations. And let's check again. 3a times -2 is -6a. +1 times 5 is +5a. When I combine those, I do get the -1a. So my answer is this factorization, the second one that did work. So 15a squared minus a minus 2 gives me the factorization of 3a plus 1 times 5a minus 2. Okay, so here's our example again. Number 4. 4x to the fourth minus 12x cubed minus 40x squared. Okay, here it is rewritten. So I have x to the fourth, x cubed, x squared. So I do have a GCF that has x squared. Now let's look at our numbers. 4, 12, and 40. I can pull a 4 out of all those numbers. So I'm going to divide each by 4x squared. So in the front, the 4's cancel. In the back, the x squares cancel. And we have some reducing in between. So 4x squared. I'm left with x squared minus 3x minus 10. Okay, so now that I factored out a GCF, what do I have left behind inside the parenthesis? I have a trinomial. And this trinomial does not have a leading coefficient other than 1. So that means I'm going to use basic factorization. So looking, I have a minus sign here. So again, just like we had before, a minus sign means 1 plus and 1 minus. So I'm going to carry down my GCF. Always make sure you are doing that. And we have x squared, so x, 1 plus, 1 minus. I go to my inner term. My inner term is negative. So that means that the negative value will be the larger number. And when I do the second category, when I have a minus, I think of my factorizations of 10, but now I subtract. So I want to subtract 2, 3. So it should say which one will subtract to 3. I'm ignoring the sign. So basically you're ignoring signs here, just thinking of the numbers. Once I identify the category, I just ignore the signs and think of only the numbers. That positive negative comes at the end when we just, we decide which one's the larger one. So which one of these subtracts to 3? So you always want to do bigger minus smaller. 10 minus 1 is 9, but 5 minus 2 is 3. Okay, so we have our two numbers. Now I come back to the polynomial. It's negative in the inner term. So again, the larger number will, the negative number will be the larger number. So in my binomials, I'm going to put the 5 with the minus sign and the 2 with the plus sign. And again, the question arises, does it matter the order in which I write the binomials? No, it does not matter. It does not matter at all. Multiplication is commutative. So the factorization for 4x to the fourth minus 12x cubed minus 40x squared is 4x squared times x plus 2 times x minus 5. Halfway there. Okay, number 5. Just going to rewrite it first. 2a to the fifth b plus 6a to the fourth b plus 2a cubed b. Okay. Lots of variables. They all have a single b, so it's going to be part of my GCF. Looking at the a cubed, a fourth, a to the fifth, so a cubed is part of the GCF. Then I have 2, 6, and 2. 2 will be part of the GCF. So I'm going to divide each term by 2a cubed b. 2a cubed b. And I go down the line and see what can be removed. So 2's can be removed from the first term and the b's. From the second term, the b's can be removed. Last term, the b's, the a's, and the a's and the b can be removed. But what does it equal when everything gets removed? Please make sure you remember that that equals a 1, which here will be positive 1 because it's a positive sign right here. All right, GCF comes first, and then what's left behind? A squared plus 3a plus 1. Okay, polynomial left behind, a squared plus 3a plus 1. Looking at this is the first category. First category, plus sign, means you're going to have either 2 plus or 2 minus. Inner term tells you what you're going to have, so it's a plus sign here, so it means I'd have 2 plus signs. And the last thing you have to say to yourself, okay, but factors of 1 that add to 3, there aren't any. 1 times 1 is 1, but 1 plus 1, because looking to add here because it's addition, plus sign means addition, 1 plus 1 is 2. So this would have to be a 2a for this to be factorable. So this is not factorable. I cannot go any further. So this would be my completely factored form. So again, the a squared plus 3a plus 1 is what we call prime. So that trinomial is prime. Cannot be factored further. Oh, I just realized I didn't go back and do the AC method. I'll do that at the very end. I'll do the AC method for number 3. I'll go back and do that. But let's just keep going. So number 6. And this one actually does the AC method right now, so this could help you a little bit. 3AB. Oh, no, I'm sorry. This does not do AC method. I'm thinking backwards. The AC method is factor by grouping. I'm flipping them around. Sorry about that. So here I have 4 terms. 4 terms, usually you want to go straight to factor by grouping. So factor by grouping. As soon as you see 4 terms, think factor by grouping. So to do that, I separate, I'm just going to carry this down. To do that, I am going to separate right down the middle. I individualize the groups. This one is treated separately from this one. So GCF, 3AB and 3A will be 3A. So I'm going to divide both by 3A. Keeping in mind again that I'm still doing the GCF times whatever is left behind. So the 3 and the A cancels from the first term. The A cancels from the second term. So I am left with B plus 3. Okay, now I gotta look for the GCF of the second set of numbers. Middle term tells you if the GCF will be positive or negative. So here we're gonna stick with a positive GCF. And it's just gonna simply be 2. There's nothing else that I can take out of 2B and 6. So the 2B gets removed from the first term. I'm left with B plus 3. So again, I removed a 3A from the first group, a 2 from the second group, and then I individually reduced them down to what I have here. I want these 2 to be the same, because now I'm going to think of the GCF of the entire expression, which in this format is that B plus 3. Cancel, 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 this is what you want to happen. Final answer. The GCF is B plus 3. What remains is what's in front and what's in front. So basically our initial 2 GCFs. And there's our final answer. So kind of the way you can think if check to see if you're doing it right. The first term will be your GCF, that is the like binomials here that you factored out in the second step. Your second term is the two GCFs from the first step. So 3a, positive 2, 3a plus 2. Common term here was ba plus 3, common term ba plus b plus 3. So that's a good way to determine if you're doing the factorization correct, factor by grouping. So 3ab plus 9a plus 2b plus 6 gives us a factorization of b plus 3 times 3a plus 2. And of course, if you were to check any of these by FOIL, you'll get back to your original expression. All right, here, number 7. X to the fourth minus 10x cubed plus 25x squared. Okay, so there is a GCF, and that GCF is just simply x squared. So I'm going to divide each by x squared. So the only thing that gets removed is the tail end x squared. So GCF times what's left behind. So x squared times x squared minus 10x plus 25. Now, question comes up, is this the PST? And the answer is yes, it's a PST. How do I know? Perfect square, plus sign. So it follows those characteristics. The inner term is negative, so that means my binomial will be negative. So how do I set it up? Always do your GCF, keep carrying it down. So now I'm going to set up my PST. I create a binomial that is squared. I carry down the sign from the middle term. And now I think what item multiplied by itself gives me x squared, which is x. What item multiplied by itself gives me 25? 5. So there is my factored form. You could have also written this as x squared times x minus 5 times x minus 5. It means the same thing. So there we have number 7. So x to the fourth minus 10x cubed plus 25x squared gives me a factorization of x squared times x minus 5, quantity squared. Last one. So 2x to the fifth plus 20 x to the fourth plus 30 x cubed. Okay, so I do have a GCF. My GCF here is 2x cubed. So divide by 2x cubed. Divide by 2x cubed, divide by 2x cubed. Front end just loses a 2, back end loses the x cubed. So 2x cubed times x squared plus 10x plus 15. This is the second category, first category, plus. So it'd either be plus, or minus, minus. Inner term is plus, so that means we're going to have plus, possibly. But then I have to think to myself, well, are there any factors of 15 that add to 10? And the answer to that question is nope. I have 1 and 15 and 3 and 5. Neither of those add up to 10. So my answer will just be 2x cubed times x squared plus 10x plus 15. That trinomial, again, is considered a prime trinomial, and I cannot factor further. Okay, so let's review the AC method now. So the example I'm going to review was that number 3. So this is 3 again. I'm just going to write the 15 a cubed, a squared minus a minus 2. And we're going to use the AC method now. So I have to identify my A, which is the item in front of the square term, my B, which is the middle term, and my C, which is the last term. So 15 is A, -1 is B, and -2 is C. My AC literally is taking the A and multiplying it by the C. So I got here -30. Okay, so looking at our characteristics, just like I did before, this is minus, so that means I'm going to have 1 plus, 1 minus. So I want to subtract to -1. But with the AC method, I'm basically taking that -1 and I'm separating it. I'm going to break this up into two expressions. So the standardized factoring that I was doing before, I am going to do that pretty much, but I'm taking it and I'm separating it before I factor further. So I carry down my first term, I carry down my last term. So now I got to think of what numbers, when I subtract, which factors of 2 when I subtract gives me +1. Again, because it's minus, I subtract. I ignore the signs. Oh, I only have the one option, which is 1 and 2. And again, it's negative, so that means the small number is positive, bigger one's negative. Okay, so now that I have that established, I'm going to come over here. And I'm going to... Oh, I did it again. I did it wrong. I'm sorry. This is not 2. I'm supposed to be doing the AC method. I'm jumping ahead of trial and error. So I'm thinking of 30. Factors of 30. That will give me a value of 1. So let me write them out. I did this in class too. Sorry about that, guys. So it's 5 and 6. Same thing though. Small number is positive. Bigger number is negative. So now I'm going to come over here and I'm going to put these two numbers in. So then these two numbers are being combined for the negative ones. Now I'm separating them. So I'm going to put plus 5a minus 6a. Oh, I have 4 terms. 4 terms means factor by grouping. Separate it down the middle. Find the GCF of each individual group. First one is 5a. Second one is -2. And why is it negative? Because I have this middle term that's negative. So they must match. So divide each by 5a in the first group. Second group gets divided by -2. And this becomes +1 because it's -2 divided by -2. All right, first group I have 5a times 3a plus 1. Same thing here. Becomes value +1. Second grouping becomes -2 times -6a divided by -2 is +3a plus 1. Identical, identical. So 3a plus 1 is my GCF. So that's what I'm going to divide each by. And what's left behind? 5a minus 2. And grab what we did for trial and error for number 3. And we got the same answer, 3a plus 1 times 5a minus 2. So any of these can be done either way, it does not matter. I don't care which method you prefer to use. As long as you're doing it right, that's all I care about. Okay, so there we go. There we have our section 5.7, mixed factoring from MAT006. I hope this video helps you review fractions. I know it's a little bit on the longer side, so feel free to, I'm hoping you guys did pause and try the questions or fast forward or even rewind, but take the time to review this video, please. And any feedback, please let me know in class or leave a comment underneath the video. Thank you very much for joining me with mixed factoring, section 5.7 of MAT006.